Namaste children. Today we are starting classes for term 2 CBSE chemistry. You know that there are two chapters are included. One is carbon and its compound and second one is periodic classification of elements. And here we are starting the first chapter, carbon and its compounds. Okay, then let us start the chapter. So here you know that carbon, its atomic number is 6. So atomic number is 6, its valency will be 4. That means in the valence shell there will be 4 electrons. So depending upon the speciality of this 4 electrons in the outermost shell, the carbon shows the different properties. So those all properties we are discussing in this chapter. So first we are discussing about the type of bond that present in the carbon compounds, and that is called as covalent bond, that you might have studied in the previous chapters and previous classes. Once again we are discussing that one. Covalent bond, it is a bond formed by sharing of an electron pair between two atoms. What is that? It is the sharing of electrons between the atoms. For example, look at here, we are discussing about the formation of hydrogen molecule. Okay, so we know that hydrogen atom has only one electron in the shell, and that is the outermost shell. So here there is two atoms of hydrogen, and we are representing two colors to understand it is easily. So here look at this, how the molecule of hydrogen is formed. Here the first hydrogen atom, it's one electron, and the other hydrogen atom, second hydrogen atom, is one electron. So these two electrons are sharing in between them. That means a pair of electron is shared in between two hydrogen atom, and these two hydrogen atom attains the configuration of 2 electrons each. This first one we are seeing that 2 electrons are present, and second hydrogen atom also gains 2 electrons. So these two hydrogen atoms become stable by forming a bond in between these two atoms by sharing a pair of electron, and they attain a stable configuration of 2, and thereby they form the covalent bond. And we can represent that hydrogen bond hydrogen, that is the hydrogen molecule, and these two represents the shared electrons, or we can write as H2 molecule. Clear this one? And this bond is called as single bond. That means only a pair of electron is shared. Okay, next we are discussing the formation of oxygen molecule through covalent bonding. Here we know that in the oxygen atom there will be 6 electrons in the outermost shell. So these 6 electron is for the first oxygen atom, and here there is a 6 electron for the second oxygen atom. So 2 electrons from each of the oxygen atom are got shared. That means there will be 4 electrons in between the oxygen atoms. And therefore look at here, how many electrons are present in each of the oxygen atom after bonding? 2, 4, 6 and then 8. So after sharing or after the formation of covalent bond, these two oxygen atoms attains a 8 electronic configuration, that is octet configuration for the stable bond formation. And here you can see that 2 pair of electrons are shared, therefore there will be 2 bonds are present in between oxygen atom to form oxygen molecule. So remember, for a single bond there is a pair of electron, and there is one more bond means there is one more pair of electrons are shared. So total 2 pair of electrons are shared, so there will be a formation of 2 bonds, and these 2 bonds are called as double bond formation. So what we can say, in oxygen molecule there is a double bond formation. And next example is nitrogen molecule formation. In the nitrogen atom we know that on the outermost shell there will be 5 electrons, and the 2 nitrogen atoms, they are sharing 3 pair of electrons between them, and both of them attain 8 electronic configuration after bond formation. And since they are sharing 3 pair of electrons, there will be a formation of 3 bonds in between the nitrogen atoms, and that is called as triple bond. So what we can say, in nitrogen molecule, what is a covalent bond? That will be a triple bond. In oxygen molecule, that will be double bond. And in hydrogen molecule, what is a bond? Single bond. So single bond, a pair of electrons is shared, and in double bond, 2 pair of electrons shared, and in triple bond, there will be 3 pair of electrons shared. Clear? Okay. Next, we are discussing about the what are the properties or specialities of molecules formed by covalent bond, that is covalent molecules. First one is they are having low intermolecular forces. That means that between the molecules there will be a weak attractive force, and because of this low intermolecular forces they will have low melting point and boiling point. And since the electrons are shared, there won't be any free electrons and there won't be any formation of charged particles. And the last one is, in most compounds, after sharing the atoms, they attain a stable configuration of 8 or 2 electrons. We know that what are the stable configurations for a molecule or atom? It is 8 or 2 electron. So after sharing, each of the atoms will attain 8 or 2, and there will be some exceptions, but now generally we are saying that there is a formation of a stable configurations of 8 or 2. Clear? Okay. Next we are discussing how a covalent bond is present in carbon containing compound. First we are discussing about a compound methane, CH4, how the CH4 molecule is formed. Look at here, the carbon atom, we know that its valence electron are 4. So this 4 green color shows the 4 electrons of carbon atom, and it is forming bond with hydrogen atom, and it is sharing 1 electron or 1 pair of electron between each of the hydrogen atoms. So look at here, 2 electron, here 1 from each electron, each atoms, and here also and here also. So between each atom, that is one carbon, this carbon and one hydrogen atom, there is a pair of electrons. So there is a formation of one single bond, single bond only. And here also a pair of electrons, so formation of single bond. Here also pair of electron, so there is a single bond, and here also single bond. And in total we are counting how many electrons are present around carbon atom after bonding. That is also how much? It is 8 electron, and each hydrogen atom attains a stable configuration of 2. So we can write it as CH4. And what is the name of the molecule? Methane. And another is example for carbon dioxide molecule. So here carbon with 4 valence electron, it is forming a shared pair of electron between oxygen atom. And look at here, what is the difference here? Here 2 pair of electrons are sharing, that is 2 electron from oxygen and 2 electron from carbon. Here also 2 electron from carbon and 2 electron from second oxygen atom. So what we can say, that between each carbon atom and oxygen atom there will be 2 pair of electrons are shared, so there is a formation of double bond. And in second oxygen atom also having the same type of bond, so there will be double bond. So between carbon and oxygen in carbon dioxide, which type of bond is present? Double bond. And after the bond formation, how many electrons are present in carbon? There will be 8 electron, and around oxygen also attains the 8 electron. So we can say both the atoms or all the atoms got the stable configuration by attaining 8 valence electron formation. Clear? Okay. Next we are studying in detail about the compounds formed by carbon and hydrogen, and they are called as hydrocarbons, and they are classified depending upon the type of bond present. How they are classified? Saturated and unsaturated hydrocarbon. Saturated means it contains only single bond. Unsaturated hydrocarbons means there will be double or triple bond is present in between the atoms. And remember, in hydrocarbon, what are the elements present? There will be hydrogen and carbon alone. There won't be any other atoms. And if there will be functional group and all, that will be studying later. And first of all, if it is a saturated hydrocarbon or it presents only single bond, we are generally calling such compounds as alkanes. ALKANES. Remember, listen this spellings very much carefully. There shows a short difference between the spellings, and that will result in the change of the compound. And second one is that unsaturated compound. In the unsaturated compound, there will be double bond as well as triple bond. So the compounds with double bond are called as alkene. ALKENES. KENES. And in the unsaturated triple bonded compounds, and they are called as alkynes. Once again, saturated compounds are compounds with single bond, and they are called as alkanes. And unsaturated compounds are of two types. One is with double bond and another one is triple bond. Double bonded unsaturated compounds are called as alkenes, and triple bonded unsaturated compounds are called as alkynes. Clear? Okay. Next we are discussing in detail about each of the hydrocarbon. First one is alkanes. And we have already said that what are alkanes? They contains only single bond in between the carbon atoms. And we have to study what should be the name or nomenclature. And this nomenclature of these hydrocarbons are given by IUPAC, that is International Union for Pure and Applied Chemistry. So before starting the nomenclature, we have to know what will be the parent name depending upon the number of carbon atoms present in it. Look at here, if the number of carbon atom is 1, the parent name or the starting name will be meth. If it is 2, eth, 3, prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. And so remember, these are the starting names of the hydrocarbon depending upon the number of carbon atoms present in it. And remember, for alkanes we have to add a name ANE at the end of the parent name. So depending upon the carbon atom, we have to write the name meth, and after meth we have to add ANE if it contains only single bond between the carbon atom. For example, an alkane with 3 carbon atom. So what will be the parent name? If it is 3 carbon atoms present, parent name will be prop. So we are starting with prop. And since it contains only single bond, so we are writing ANE. So from the name itself we can understand what is the type of hydrocarbon. So prop means we know how many carbon atoms present. Prop means 3 carbon atom, and ANE represents it is an alkane. Clear? Okay, so we said that nomenclature or naming of hydrocarbons are done by IUPAC. So next we have to study how to write the structure of alkane by giving the name or by getting the name. So here the compound is methane. So from the name itself we can understand meth means how many carbon atom? There will be only 1. ANE means single bond. There is a 1 carbon atom only. So the ANE is no that much meaning here. So methane. So first of all we have to write the carbon atom. And remember, around each carbon atom there will be 4 single bond. How it came? That means at the outermost shell of carbon atom there will be 4 electron. So each 4 electron has to attain 4 more electron, and that will form the 4 single bonds around them. So remember always, each carbon atom should be surrounded by 4 bonds or 4 single bonds. If it is double bond or anything, around carbon atom there will be only 4 bonds. So after that we are putting 4 bonds around carbon atom, and there won't be any other carbon, we are just putting the bond. And with the bond we know that what is the other element present in hydrocarbon? That is hydrogen. So all the 4 bonds will be satisfied by the 4 different hydrogen atom. So carbon atom that is surrounded by 4 hydrogen atom with single bond. So the molecular formula is 1 carbon C, and H, how many hydrogen it is? CH4. So the molecular formula is CH4, and this is the structure of that methane. Clear? Okay, second example is ethane. From the name we can know ethane means 2 2 carbon atom, and since the name is ends with ANE, so there will be single bond in between the carbon atom. So this is the first step, writing the carbon atom number and putting bond in between the carbon atom. And second step is that satisfy all the 4 bonds around the carbon atom. So here the first carbon atom, if you look at the first carbon atom, there's already one bond with the second carbon atom. So how many bonds are remaining? 3 bonds. So we have to put the 3 bonds around this carbon atom. And if you look at the second carbon atom, there is also one bond is already formed. So we have to put the 3 bonds remaining around it. So we can say around each carbon atom there will be 4 bonds. So both the carbon atoms satisfied the 4 bonds. The next step is that we have to put the hydrogen atoms at the bonds. So around this carbon atom there will be 3 bonds are free. So we put 3 hydrogen atom, and here also 3. And in short we can write first carbon atom C, around it there will be 3 hydrogen CH3, and between the carbon atom there will be single bond, and after that again we wrote CH3, or in short we can write there will be 2 carbon atom C2, and in total hydrogen atom 6, so C2H6. So here I have written 2 more examples, that is propane. Prop means how many carbon atom? There will be 3. So what first step? We have to put the 3 carbon atom, and the name ends with ANE, so we have to put single bond between each of the carbon atom. And then what is the next step? We have to put the bond remaining around each carbon atom. What should be the number of bonds around each carbon? That will be 4. So if you look at the first carbon, one bond is formed with the carbon atom, so there will be 3 remaining bonds. And if you look at the second carbon atom, there will be 2 bonds are formed with the adjacent carbon atom. The one bond with the first carbon atom and the other bond with the third carbon atom. So there will be only 2 bonds are remaining, so that we put above and below. So there will be 2 hydrogen bonds, 2 bonds with that of with hydrogen atom, and at the last carbon there will be 3 hydrogen atoms are present with the bond. So the molecular formula will be CH3 bond CH2 bond CH3, CH2 bond CH2, CH3 bond CH2 bond CH3, or in short we can write C3H8. And the fourth one, 4 carbon butane. So we have to put the 4 bonds, 4 carbon atoms, and there will be 3 bonds in between the carbon atom, and satisfy the remaining bonds around each carbon atom. So we got CH3 bond CH2 bond CH2 bond CH3, or you can write CH3 CH2 CH2 CH3, or in short there will be 4 carbon, so C4, and 10 hydrogen C4H10. Clear this one? So we can understand from this structure, the first carbon should be satisfied with 4 hydrogen CH3, first and last one CH3 CH3, and in between this all the carbon atom contains only 2 hydrogen atom. Clear this one? Here look at here, CH3 CH3, and the middle one is CH2, and here the first and last is CH3, and in between the 2 are CH2. So we can, in general we can say that at the starting and ending of the structure of the hydrocarbon there will be CH3 CH3, and in between that there will be CH2 if no other groups are present. Clear? Okay, so for the next class we will discuss the remaining portions. If you like this video, please like, share and subscribe. After that only I can continue the remaining portions. Clear? Thank you.